On a cold morning in January 1945, at a remote airstrip in northern China, Japanese soldiers tightened their circle around a lone American fighter that had just touched down. The pilot, First Lieutenant Oliver Strawbridge, was immediately taken into custody. But it wasn't the man who would leave a mark on history. It was the aircraft he flew. A P-51 Mustang, sleek and unscathed, rested on enemy soil. To the Japanese Army Air Force, this plane represented a prize beyond imagination, one that would expose a reality too stark to confront. For over a year, Japanese pilots had been falling to this new American fighter in record numbers. Every dogfight told the same story. The Mustang was swifter, more powerful, and nearly untouchable. Unlocking its secrets became urgent for the Japanese, desperate to find a weakness that could restore the balance in the sky. They knew the stakes of capturing enemy aircraft. The Americans had proven this after seizing a Zero at Midway. That single aircraft had exposed critical flaws, giving American pilots the edge to reclaim air dominance. And now, in the bitter winter of 1945, the roles were reversed. Within days of the aircraft's arrival at the Japanese airfield, Evelina had been restored to an almost pristine condition. The scars of battle were carefully removed, and Japanese Hinamaru markings were hastily repainted over the American stars. The fuselage gleamed with a silver brilliance, and the menacing open red dragon mouth on the nose glared as if alive. On its side, kill markings denoted victories over Japanese pilots who had never returned home. This was not just a plane, it was a mirror, reflecting the harsh truth of the enemy's technological supremacy. The assignment to ferry the Mustang to Japan fell to Yasuhiko Kuro, a 30-victory ace with years of combat experience. He was aware that he would be the first Japanese pilot to truly grasp what the Americans had achieved in engineering and tactics. As he climbed into the cockpit at the makeshift Japanese airfield, he felt a twinge of unease mixed with anticipation. He turned the key and the Packard Merlin engine roared to life. There was no hesitation, no trembling idle, only the smooth hum of controlled power. Kuro had flown countless Japanese aircraft in his career, yet none had ever felt so precise. Japanese engines, even brand new, were prone to vibration, uneven throttle response, and occasional oil leaks, a tolerated hazard of wartime scarcity. The Merlin, in stark contrast, was dry, tight, and flawless. To Kuro, the absence of oil leaks was not merely aesthetic, it was revolutionary. It spoke to meticulous craftsmanship, uncompromising quality, and industrial consistency that Japan simply could not replicate. Kuro eased the plane into the sky. The controls responded instantly and predictably. A high-speed dive revealed more surprises. Japanese fighters often shuddered under the stress of rapid descents, their frames trembling as gravity pulled them downward. Evelina, however, cut through the air with unshakable stability, almost as if the sky itself had welcomed it. Landing at the Army Air Inspection Center in Fusea, Kuro was greeted by a throng of engineers, test pilots, and intelligence officers. The question on everyone's lips was simple. How does it fly? Kuro's response was understated yet lethal in its implications. Better than anything we have. The words carried weight because they came from one of Japan's finest. The Mustang's performance exceeded even the vaunted K-84 in a horizontal turn, a point of reference every Japanese pilot respected. Beyond raw flight capability, Kuro noticed the communications equipment. The radio was clear, reliable, and sophisticated, a stark contrast to the barely functional sets in most Japanese aircraft. Real-time coordination between American formations, the ability to execute complex tactics like the thatch weave, and access to live intelligence in combat were all baked into the Mustang's design. Furthermore, the directional beacon could guide a pilot home in bad weather or if wounded, a device that could literally save lives, something Japanese engineers had rarely prioritized. In the American system, a trained pilot was as valuable as the aircraft itself. Survival, not sacrifice, was part of the philosophy. Following Kuro's initial flights, another ace pilot, Yohei Hinoi, approached Evelina with a unique perspective. Hinoi had previously shot down a Mustang in 1943, only to be downed by another Mustang shortly afterward, costing him a leg. Now flying with an artificial limb, he approached Evelina not only with professional curiosity, but also with a personal reckoning. Climbing into the cockpit, Hinoi immediately noticed the spaciousness. Japanese fighters were notoriously cramped. The Zero, for example, treated pilots like disposable components, a small part of a larger machine. The P-51, by contrast, was designed around the pilot's comfort and awareness. He noted the bulletproof glass, the steel-encased seat, and the oxygen system. These features were not mere luxuries. They were design choices that prioritized pilot survival and effectiveness. The more Hanoi explored, the more the technological gulf became evident. Japanese pilots had long endured minimal protection, fragile frames, and unreliable instruments. A single well-placed hit could remove a veteran ace from combat, leaving a cadet to fill the void. Evelina, in contrast, was built to absorb punishment and return its pilot safely. Every aspect of its construction reflected an investment in human capital, something the Japanese system could neither emulate nor afford at scale. While pilots tested the aircraft in flight, engineers dissected the Merlin engine on the ground. Every component, every tolerance, every machining process demonstrated precision beyond anything Japanese factories could achieve. Intelligence reports confirmed the engineers' findings. Packard was mass-producing engines at a scale that dwarfed Japan's total wartime production. Where Japan could produce roughly 60,000 engines across all types during the entire war, a single American engine type had already neared that number. The implications were staggering, chilling even the most seasoned observers. The analysis was not limited to engines. Every part of Evelina, aluminum airframe, electronics, avionics, and even minor systems, revealed the Americans' industrial depth. High-grade materials, precise assembly, and quality control combined to create a product that Japan could admire, but never hope to replicate. Even with desperate improvisation and the best pilots, there was no way to overcome the quantitative and qualitative advantage inherent in the Mustang's design. Evelina was transferred to a Kino flying division, tasked with mock combat against Japan's top fighters. The Ki-43, Ki-61, and Ki-84. The results were sobering. In maneuvers requiring high energy, dives, rapid climbs, and zooms, the Mustang held absolute dominance. Even the most skilled Japanese pilots could not counter the Mustang's advantages. Kuro, reflecting on the flights, admitted a stark truth. In the cockpit of Evelina, he feared no Japanese fighter. High-speed tactics that relied on energy management and momentum rendered Japan's lighter, more fragile aircraft almost obsolete. To adapt, Japan organized a flying circus of captured Allied planes, touring units, and teaching survival techniques rather than offensive strategies. The focus was no longer victory, it was endurance, and even then it was a temporary measure. Engineers compiled a technical report detailing the Mustang's capabilities and comparing American and Japanese industrial output. Yet when forwarded up the chain of command, the report was quietly ignored. Acknowledging Evelina's superiority was politically impossible, threatening the ideological foundations of the Japanese war effort. Officers who presented unflattering data were demoted or reassigned. The truth about Evelina was effectively silenced, confined to technical documents that few would read. After several months of flight tests, Evelina's fate was sealed not by enemy action but by a simple mechanical failure. The electrical generator burned out, and Japanese engineers, constrained by materials shortages and a collapsing industrial base, were unable to manufacture a replacement. Evelina, the aircraft that had revealed so many uncomfortable truths about Japan's industrial inferiority, was grounded. Its silence, however, did not diminish the lessons it had imparted. Pilots who had flown it, Kuro and Hanoi among them, retained a visceral understanding of the gulf between Japanese and American engineering. The Mustang had shown that the outcome of war was determined not by courage alone, but by the relentless application of industrial power, quality manufacturing, and strategic resource allocation. Even as the aircraft sat immobilized, calculations derived from fuel consumption and range tests proved prophetic. By late 1944, P-51s were escorting B-29 bombers on missions from Uoyama to Japan. Japanese defenders scrambled to intercept, but the numerical and technological disparity was too great. Evelina's lessons were being applied on a scale beyond any single test flight. The Mustang was no longer a captured curiosity. It had become a symbol of the industrial and tactical inevitability facing Japan. Technical reports continued to circulate within Japanese command structures, documenting the P-51's superiority in flight performance, pilot survivability, and manufacturing consistency. But acknowledging these facts posed a political and psychological threat to leadership steeped in ideology. Reports were dismissed as defeatist, and officers advocating for adaptation were quietly sidelined. Evelina's revelations contained within official documents became a hidden testament to the limits of Japanese industrial warfare. The story of Evelina was not unique. Across Europe, German engineers had examined captured American aircraft and reached identical conclusions. Yet ideological rigidity, emphasizing spirit over material, blinded military leadership to the empirical realities of industrial competition. In Japan, as in Germany, competent observers could articulate the problem, but there was no appetite for confronting the uncomfortable truth. The full scale of American production was staggering. By 1945, the United States had produced over 300,000 military aircraft. Japan's output hovered around 70,000. Among these, the P-51 Mustang was produced in approximately 15,600 units, alone outnumbering Japan's two most numerous fighters combined. This disparity was compounded by the consistent quality of American aircraft, which maintained or improved standards even as production scaled upward. Engineers examining Evelina noted that the Packard Merlin engine, responsible for much of the aircraft's performance, represented industrial and technological achievements Japan could not replicate. Total production of the Merlin exceeded 55,000 units, powering multiple aircraft types in both American and British service. Japan's total engine production across all types barely reached the same figure. In other words, for every engine Japan produced, the American system was delivering almost an equal number of a single superior type. The strategic implications were unavoidable. The Mustang's combination of speed, maneuverability, range, and pilot safety allowed the United States to implement high-energy tactics, dominate airspace, and protect bomber formations with unprecedented efficiency. No matter the skill of Japanese pilots, no matter the bravery of a few aces, the industrial disparity dictated the outcome. Evelina had revealed a reality that could not be reversed through courage or ingenuity alone. By mid-1945, Japan's efforts had shifted from offensive air operations to survival tactics. Kuro's flying circus toured Japanese units, teaching pilots how to evade superior aircraft rather than confront them directly. Techniques focused on survival, avoiding the Mustang's line of sight, minimizing exposure, and breaking the energy advantage of high-speed dives and climbs. The emphasis was no longer victory. It was the preservation of lives in an increasingly hopeless situation. Years later, both Kuro and Hinoi reflected on Evelina with a mixture of awe and unease. In the cockpit of the Mustang, Kuro had felt invincible, an expert pilot capable of defeating any Japanese fighter. But the knowledge of industrial limitations, the inability to replicate such machines, and the overwhelming American output left an indelible mark on him. Hinoi, flying with an artificial leg, remembered the aircraft as a revelation, spacious, protective, and meticulously engineered, a stark contrast to the cramped and fragile fighters he had flown. Evelina's story mirrored the larger trajectory of the war. In 1942, Americans had captured a Japanese Zero, identified its weaknesses and adapted tactics, eliminating Japanese air superiority in months. In 1945, the roles were reversed. Japan captured Evelina, but instead of weaknesses, they found strengths they could not match. Tactical adaptation could only teach survival. It could not overcome the overwhelming quantitative and qualitative advantage of American industrial power. Ultimately, Evelina became a silent witness to the central truth of the conflict. Ideology and courage could not overcome material capability. While Japan clung to notions of spirit-driven victory, the United States had leveraged resources, industrial scale, and engineering precision to achieve undeniable dominance. The Mustang's performance, mass production, and survivability were not anomalies. They were manifestations of a systematic approach to warfare that valued both machine and human life. The captured P-51 Mustang, grounded and forgotten after a burned-out generator, served as a historical mirror. It reflected not only the technological gap between two nations, but also the consequences of industrial philosophy, resource management, and strategic foresight. Evelina's legacy was measured not in dogfights or victories, but in the cold arithmetic of production numbers, fuel efficiency, and engineering excellence. In every sense, the Mustang had revealed a truth Japan could not ignore. The war had been unwinnable not because of courage or skill, but because of the stark, unalterable realities of industrial capacity. The contrast revealed more than just differences in aircraft. It exposed a fundamental truth about how wars are won. American strategy relied on facts, data, and the relentless refinement of processes, while Japan's system could only interpret those same facts as proof of despair. On that fateful day when Evelina touched down in Japanese hands, she did more than sit in a hangar. She exposed the reality no ideology could obscure. For a brief moment, engineers and pilots alike confronted the full scale of their disadvantage. Evelina's lessons were clear. Courage could inspire, skill could achieve feats of brilliance, but material and industrial superiority could render both irrelevant. The Japanese officers who examined her understood the mathematical inevitability of defeat. They saw that the war was no longer a contest of valor, but of production, precision, and strategic resource. They reported their findings, but no action could reverse the imbalance. In the cold, unyielding logic of modern warfare, Evelina became more than a captured plane. She became a symbol of industrial destiny. Her engines, her airframe, her every rivet whispered the immutable truth. Victory favors those who can produce, adapt, and sustain at scale. And in that lesson lies the enduring moral of her story. For every aspiring strategist, historian, or curious mind watching today, Evelina reminds us that understanding the machinery of the world, whether in war, industry, or life itself, is as crucial as mastering the human spirit. Courage, determination, and skill illuminate the path, but without the power of preparation, resources, and foresight, even the bravest efforts may be swept aside. Let Evelina's story be a call to measure your challenges honestly, act decisively, and never underestimate the quiet, unassailable force of capability.